Hey all, let's solve that challenging application problem that we didn't get to in class. Remember, we're solving inequalities, so our answer is going to be an inequality. So remember, we've got this object. It's a pretty cool situation, right? You've got an object that's placed a certain distance away from a lens, right? And there's a certain focal point for the lens, depending on how steep the slope of the ellipse is, the elliptical part of it is. It's called the focal point. And if you put the object further away than the focal point, then it'll project an image on the other side, q units away, according to this relationship. So it's a pretty cool little relationship. I didn't actually know this before doing this problem. So what we're going to do is we're going to solve the problem, right? If we have a certain a lens with a certain focal point, right? In this case, it's f equals 5 centimeters. Then we want to know how close do we need to put the object to the lens so that the image is more than 12 centimeters from the lens. Okay. So what we're gonna do is we're gonna solve for Q in terms of P, and then we're gonna replace Q with 12, and for an inequality, right? And then we're gonna use the inequality Q is greater than 12, and we're gonna solve for P. That's gonna be the approach that we use, right? So we're given this equality 1 over P plus 1 over Q equals 1 over F. So first what we're gonna do is we're gonna let F equal 5 centimeters. And we're going to solve for Q in terms of P. Right? And we're just going to do an equality, right? Just an equality straight up. So we've got, in fact, maybe, let's see. So we've got, should we do it over now? We have enough space over here. So we're going to have 1 over P plus 1 over Q equals 1 over F, which is 1 over 5. Let me move this down a little bit. We got a little more space than that, right? Okay. And then what we're going to do is we are going to try to solve for Q, right? So we're going to maybe subtract the P over. So we're going to get 1 over Q equals 1 over 5 minus 1 over P, right? And now what you could do is you want to just sort of flip the top and the bottom, but you can't quite do that because we're subtracting fractions. Well, we do know that 1 over 5 minus 1 over P is really P minus 5 over 5P. And that means that, right, if we can either cross multiply or just flip all the fractions, flip both the fractions. So we have Q over 1 equals 5P over P minus 5. Okay, so we have this. We did what we wanted to do. We solved for Q in terms of P. Now, remember, the problem is asking how close must the object be to the lens? Well, we know that that's P, right? P centimeters from the lens. For the image to be more than 12 centimeters from the lens, right? The image is more than 12 centimeters from the lens. So really what this says is solve for P so that Q is greater than 12. That's what we're solving for. So now, solve for P so that the inequality holds. Okay? Now, and this, similar to an equality, we just need to be careful here because multiplication by negative numbers is problematic. However, I think we're okay because remember that two things. Number one, P is greater than 0, and in fact, P is greater than F, which is equal to 5. right? That was one of the assumptions we made, right? P is greater than F. It doesn't really make sense to talk about P being less than F. We're always assuming the object is further away than the focal point. So that means that 5P is greater than 0. What? And actually, so is P minus 5. So now we can just do a bit of arithmetic here, and we should be good. So I'm going to multiply both sides by P minus 5. I'm going to get 5P is greater than 12 times the quantity P minus 5. And that implies that 5P is greater than 12P minus 60. And now what we're going to do, let's see what we should do. We're going to subtract 12P from both sides. So that implies that negative 7P is less than negative 60. And then for our final answer, we're going to divide by negative 7, right? So you have P is less than 60 over 7, right? Be a little careful, right? We're dividing by a negative. You have to switch the order of that. Okay, but that's our answer. And if we look, and maybe we should actually be a little careful, right? Just put in some units, centimeters. But if we take a look at the problem, the wording of the problem, that seems to make sense. How close must the object be to the lens for the image to be more than 12 centimeters from the lens? Okay? So that suggests that we're trying to make our object close. Okay? Now again, if you want to be super precise, then you could say that, P is between 67ths on the upper bound and, I guess, 35 centimeters on the lower bound. Maybe I'll just put this in right here. So 35 centimeters is strictly less than P is strictly less than 67 centimeters. Right? Because again, we're assuming P is greater than F. But you wouldn't, if I ever asked you this sort of problem, it's a little challenging, but if I ever asked you this sort of problem, unless I were specifically asking for the lower bound, then you wouldn't need to include that. It'd be a nice touch, but you wouldn't need to. Okay? So, nice little application. I learned something new about lens formulas with this, but that's how inequalities can be useful. Thanks for watching.